So we use an iterative approach called the expectation maximization algorithm, or EM.
EM. Oh,
It's a really clever two-step process that cycles back and forth.
Let's try to break down those EM steps conceptually, maybe without getting lost in the math.
Okay, we start with the E step, the expectation step. This is where, for every single data point, we calculate the probability that it belongs to each of the K components.
Ah, so not just assign it to one.
No, this gives us what are called responsibilities. It's a soft assignment. It might tell you, okay, this data point has a 70% chance of belonging to component A, a 25% chance of belonging to component B, and a 5% chance of belonging to component C.
So the E step gives us probabilities,
Yeah.
a measure of belief or uncertainty about where each point fits.
Precisely. That's the conceptual power over K-means. It handles ambiguity. It tells you how confident it is about the assignment.
Okay, that's the E step. What about the M step?
Then we move to the M step, the maximization step. This is where we use those soft assignments, those responsibilities we just calculated.
The 70%, 25%, 5%.
Yes, we use those probabilities as weights to update all the parameters, the means, the covariances, and the mixture weights for all K components.
So we use those probabilistic beliefs to refine our definition of each underlying Gaussian distribution.
That's it. The E step computes the soft assignments based on the current parameters, and the M step updates the parameters using those soft assignments. It iterates back and forth, E then M, E then M.
Similar to K-means iterating, but conceptually very different.
Very different. It keeps adjusting the statistical definition of each cluster until the model finds the parameters that maximize the overall likelihood of observing the actual data you fed it.
That conceptual difference is really key. K-means finds groups using hard physical distance. GMM finds groups using statistical probability and handles uncertainty, handles overlap much more gracefully.
Absolutely. If you suspect your clusters overlap or have non-spherical shapes, GMM is generally going to be a much better, more realistic choice. It doesn't force those artificial hard boundaries.
Okay,